Hello there, all of my wonderful Math 2 students. I hope you are as excited about e-learning as I am. Today's assignment, quote unquote, will be to basically watch the video here, learn what we would have been doing in class today. Tomorrow's assignment will be the worksheet that I would have given you that would accompany this worksheet. So that will get you through the first couple of days. This will be an extension of what we did Friday. Just doing these problems with word problems, finding angles and sides using sines, cosines, and tangents, our trig functions. So to begin, if you look at what we have here, you're going to see two different things, what we would call an angle of elevation. Pretty self-explanatory here. If this is where we are looking, where we're standing, this is our flat surface, the ground, earth, whatever. And if we look upwards, then obviously we would create an angle between where we're looking up and the ground. Elevation obviously means go up. So it's the angle that we would create by looking upwards. An angle of depression is an angle where we're actually looking down. So this is now kind of our horizontal. So think about if you are standing on top of a building and you look down to somebody on the ground, the angle that would be sort of you looking straight ahead, and the angle that is created by you looking downwards is what we would call an angle of depression. Okay? Using those two ideas with these word problems, along with sine, cosine, and tangent, is ultimately kind of what we're getting at with this lesson. So an angle of elevation and depression problems are word problems where you need a picture to represent the situation in a problem. If you sort of notice here, if I drop down what we would call an altitude, we create a right triangle. Here, if we go up, we can create a right triangle. So what we're using then, or what we are allowed to then use, are things like the Pythagorean theorem and then sines, cosines, tangents. So if you look at this first little setup, a ladder is leaning against a wall. If the base of the ladder is 26 inches from the wall, so that would mean that this is 26. The angle of elevation of the ladder to the floor is 55 degrees. So that would be this. So this is 55 degrees. Find the length of the ladder, which means we're looking for this here. How long is that ladder? We labeled everything, so let's just put first, put the measurements in the correct place on the picture. We've done that. Second, label the missing side with a variable such as x. We've done that. Third, write the appropriate labels, hypotenuse, opposite, and adjacent on the sides shown. So if this is our reference angle, 26 is what we would be calling the adjacent side. X is what we would be calling the hypotenuse. So if you remember, if this is our angle and we're talking about adjacent and the hypotenuse, the trig function that we would be using, remember sine is opposite hypotenuse, cosine is adjacent hypotenuse, tangent is opposite adjacent. Since again we have the adjacent side and the hypotenuse, adjacent hypotenuse means we'd set up a cosine. So that's what we have here. The cosine of that 55 degree angle would be the adjacent side, so this one. So that's why we have the 26 on top. Over your hypotenuse, that would be the ladder, and then that is our x. Set up a number of these on Friday in class. We would then, to solve this, multiply both sides. Let me clear this out. Multiply both sides by x to get it out of the denominator. The x ends up on the other side. That's where this equation comes from. Divide by that cosine of 55 degrees. Pull out our calculators, punch that in, and then that's our angle. I'm sorry, that's the length. So what that tells us is the length of our ladder is a little bit over 45 inches. All right. That's the setup for most of these. Just setting up a little right triangle from our picture. And then once we have that set up, identifying if we want to be using sines, cosines, or tangents. All right, so number one, it says from a point on the ground 25 feet away from the base of the tree. So from the base of the tree on the ground. Those keywords tell us this 25 is this length. The angle of elevation at the top of the tree is 48 degrees. Find the height of the tree. So since the height of the tree is what we're looking for, that's going to be our variable. So think of a right triangle here where the tree is at. That is your x. That's the variable. This all again goes back to sine, cosines, and tangents. So if this is our angle, the sides that we are now working with, this is the opposite side. This is our adjacent side. So opposite over adjacent is in terms of SOHCAHTOA, the TOA. So the tangent, opposite, adjacent. So we're going to set up tangent of our angle. That would equal the opposite over the adjacent. So for us, in this particular problem, we now actually plug some stuff in here. We would do the tangent of our angle, the angle being 48 degrees, is equal to the opposite side, which is x, and the adjacent side, which is 25. Multiply both sides by 25, so that our answer should be whatever this would evaluate to be on your calculator, which I need to now plug in. So that our final answer, we got 25 tangent 48 is 27. What did I do here? Round final answer to 2 decimal places, 7 and then 0.77 feet. 2, a 22-foot ladder. So there's our ladder. So that's 22 feet. Leans against the tree. The top of the ladder is 12 feet above the ground. So that would be basically mean from the top of the ladder straight down, that is 12 feet. We then want to find the angle the ladder makes with the ground. So here's our ladder. Here's the ground. It means we're looking for this angle. Call that theta. That's what we're trying to find. If this is the angle that we're looking for, we know the opposite side. This is our hypotenuse. Here's our right angle, so that's our hypotenuse. So this looks like it's 72. So this is the opposite hypotenuse. So if you remember, sine is the opposite over hypotenuse. Sine, opposite, hypotenuse. So we're going to set up the sine of this angle. That would equal the opposite side of 12 over the adjacent side of 22. To evaluate this will now give us our angle. If you remember, you've got to find that second sine key, the one that looks like sine raised to a -1, and then of 12 over 22. Cannot do that without the calculator. So again, you're going to do, now that's the second sine, so you do the sine to the -1, type in that fraction, 12 divided by 22. And we find that our angle is 33.06 degrees. 3, the forest fire watchman is 100 feet, or is in a 150-foot tower. So that tells us that this here is 150 feet. He spots a fire in the distance. If the angle of depression, if you remember, the angle of depression is made from the top down. So that is this length, or this angle here. Let me do it this way. Get rid of this. So that angle is 37 degrees. How far away is the fire? And this is asking an actual horizontal ground distance. So we are looking for this. All right. So this quick little review. What we have to understand is that this line and this line are parallel. They're both horizontal lines. Because they are parallel, if you remember, this is what we had called back in the day a transversal. This angle now with this angle here have to be congruent. So if this angle was 37, this angle here would also be 37 degrees, because if these are our horizontal lines, which they are, this is our transversal, this angle are what we were calling alternate interior angles. We know alternate interior angles are congruent. So what that allows us to do now is focus on this triangle, because if we can figure out, because we now have all of this information, we were looking for this x. So because this was 37, this must also be 37. If this is 37, the sides that we are given to work with are the opposite side of 150 and the adjacent side of x. So again, opposite over the adjacent is the tangent, the TOA part. Because it's a tangent, that's what we set up. The tangent of our 37 degree angle would be the opposite side of 50 over the adjacent side, which is the x. Multiply both sides by x. Divide that tangent of 37 over. Pull out the calculator. Give me a second. And we find that we are 66.35 feet away from the fire. Four, large totem pole is 120 feet tall. So there's our totem pole. I don't know why it looks like that. At a particular time of the day, the totem pole casts a 318-foot long shadow. So sun's over here. The shadow is this guy. You were told that that is 318 feet. Find the angle of elevation made from the end of the shadow. Here's our shadow, the end of it, and the line of sight to the top. And so we are looking for that angle there. If that's our angle, we have opposite, we have adjacent, it's another tangent because of that. So we would say the tangent of our angle, why is it doing that? Would equal the opposite side of 120 divided by the adjacent side of 318. To solve this, we have to hit that second tangent key since we're now looking for the variable. Let me throw that into the calculator for you real quick. So second tangent is what we type in, and then of 120 divided by 318. And should get 20.67. All right. 5, you lean against the wall, making a 63 degree angle with level ground. So now we're going to create our own picture. So here's our wall. Here's you. You're leaning against the wall. The angle we make is a 63 degree angle with the ground. I'm sorry. You lean a ladder against the wall, I should read. If the ladder rests 1.7 meters from the base, so here's where the ladder would rest. It is 1.7 meters from the base of the wall. So this is our 1.7. So here's our angle. That's not real clear there. Let me write this a little better. So this length here is 1.7 meters. Question is, how long is the ladder? So here is our ladder. That's what we'd be solving for. If this is our angle, we know the adjacent side. Here's our right angle. So here is your hypotenuse. So adjacent over hypotenuse is that part of our SOHCAHTOA. So that is cosine. So cosine of the adjacent side. Sorry, let me get rid of this. This is the cosine of our angle, is 63. that would equal the adjacent side of 1.7 divided by x. Solve this for x. So we multiply that x over. These will cancel. So currently we have so currently we have x times cosine of 63 degrees equals 1.7. X would then equal that 1.7 divided by cosine of 63 degrees. Calculator time. So 1.7 divided by cosine 63, 3.74 meters. All right. Okay, let's do a couple more here. I think at this point we're understanding or not. Let's do an angle depression. Actually, let's do 6 and 7 here. A person is 6 feet tall, cast a shadow that is 13 feet long. So think about, here's a person. Beautiful. Actually embarrassing. Let me get rid of that. So your person is standing straight up. So there is him. He's 6 feet tall. He's creating a shadow, so the shadow would be along the ground. So here's our ground, 13 feet. The sun would have been over here. So that's sort of how we're creating our right triangle. What is the angle of elevation from the tip of their shadow up to the sun? So here's the tip of the shadow. Here would have been our sun. We are looking for this angle. So that's the variable that we are trying to solve for. So we're looking for this angle. We know the opposite side and the adjacent side. We don't know our hypotenuse. So opposite over the adjacent is the TOA. T-O. T is your tangent, opposite, adjacent. So tangent of this angle, which we don't know, has to be the opposite side of 6 divided by the adjacent side of 13. Solving for the angle requires us to do that second tangent, so that tangent to the -1 key, 6 divided by 13. Give me a minute. Second tangent of 6 divided by 13. And our angle would be 24.78 degrees. All right. All right, do one more. We'll find an angle of depression. At least one more angle of depression. Number 7. So an angle of depression from the top of a building to the point on the ground is 48 degrees. So I'll draw this building here. So we're talking the top of the building. Let's make this our point on the ground. So again, the angle of depression means if we're looking straight out to the horizontal, we're looking straight horizontally out. And then we look down to this point on the ground. The angle of depression is formed from us looking straight out to whatever we're looking for. In this case, it was this point on the ground. So this angle here is 48 degrees. But we talked about before, the horizontal line that we're looking out from the top up here, and then think about the ground as a horizontal line too. This horizontal line and this horizontal line would have to be parallel. So what always then happens is this line that we're looking towards is our transversal of these two horizontals, parallel lines. So that's 48 degrees here. Then its alternate interior angle must also be 48 degrees. You're then told that the point is 50 feet from the base of the building. So here's our point. Here's the base of the building. So this is our 50 feet. The question then is, how tall is the building? That's going to be your x. So then we really now focus on this triangle here. And if we consider this as our reference angle now, so this guy here is our reference angle, We know the opposite side. We know the adjacent side. So it's another tangent. Tangent is the opposite over the adjacent. So the tangent of our angle of 48 degrees is equal to the opposite side of x over the adjacent side of 50. X would then multiply by 50 to both sides. Would have to be whatever 50 times the tangent of 48 is. So give me a minute. 55.53 feet. Okay. Okay, last one. We'll go to number 9 just so you see another angle of depression problem. So students in a hang gliding class stand on top of a cliff. So here will be our cliff that is 82 meters high. They watch a hang glider land on the beach below. So we'll say this is our guy landing on the beach below. The angle of depression to the hang glider, again, hang glider is the guy on the ground, is 72 degrees. So if they're on top of the cliff, here is the horizontal if we're looking straight out. They're not looking straight ahead. They're looking down at the hang glider who has landed on the beach. The angle of depression then is made from looking straight out to the angle they're looking down at. So this angle here is the angle of depression. It's 72 degrees. The question then is, how far is the hang glider from the base of the cliff? So here is our hang glider again. Here's the base of the cliff. We are then looking to see how far away the hang glider is from the base of the cliff. So that's our variable. So again, here's horizontal line on top, horizontal line on the bottom. These would have to be parallel. That makes this angle and this angle alternate interior angles, and we know alternate interior angles are congruent. So now we can just talk about this triangle where we have our x, our 82, and then that angle. So from this angle here, we know again the opposite side, we know the adjacent side. So yet again, it's another tangent, opposite, adjacent. So tangent of the angle that we know, which is 72 degrees, is the opposite side of 82 over the adjacent side of x. At this point, we should be pretty good with solving these. Multiply both sides by x. Divide, well, let me not skip too many steps here. So our next thing we have is, x times the tangent of 72 is equal to 82. We then have to divide by the tangent of 72 to get x by itself. Can only do this on the calculator. So we divide these. Just make it look just like what it looks like on the paper on your calculator. And we get this to be 26.64, I think it was, our meters in this case. Yeah. So that's pretty much everything that we would have done in class today. I'm going to go ahead, so this will be your assignment for today. I have, or will be, if I haven't, attached your assignment that would have accompanied this. I would just encourage you then to do that tomorrow so we stay up to speed with everything. And then Wednesday, I'll have something new. So enjoy your day of e-learning. Hopefully this made some sense. If you don't have a calculator, get one. I did not bring my calculator home. I put it on my phone, so you can easily get a free calculator on your phone now, and then just to make sure you know how to use that. Anyway, enjoy the rest of your day. We'll talk to you guys on Wednesday.